Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5. Our title is Live Flowing Mobile Robot with Measured Temperature and Humidity. This is our team. The first one is AMIR, second is IQHRAM, third is FAKHRUL, fourth is SYAHMI, and last one is RAZEE.
Assalamualaikum and good evening. My name is Muhammad Ahmad KAMAL. My metric number CN210153. So I will explain for the introduction for the line following robot. So for the introduction, a mobile device that can recognize and follow a line drawn on the ground is called a line follower robot. The path is typically predetermined and might be either visible, like a black line that is highly contrasted in color on a white surface, or it could be undetectable like a magnetic field. This type of robot should unquestionably use its infrared IR sensor, which are mounted beneath the robot to detect the line. Following that, particular transition bus carry the data to the CPU. As a result, the Q-follower robot will follow the path after the processor determines the appropriate commands and delivers them to the driver. The combining with DHT11 features for temperature and humidity, the following mobile robot will be detected with this feature in hot and humid areas.
The problem statement of this project is a line-following mobile robot is being developed to perform multiple tasks simultaneously, including displaying the robot's group number and name, prioritizing line-following operations, and measuring temperature and humidity using an OLED screen. The system must balance environmental monitoring with line-following functionality, integrating complex algorithms, control systems, and sensor technologies. The successful completion of this project will result in a smart robot that performs well in its main function and displays adaptability by performing multiple tasks simultaneously. So there are three objectives in this project, which is the first one is to ensure line following mobile robot follows a predetermined path based on detection using IR sensor. The second one is to become familiar with how to use Arduino Uno to develop an embedded system process. Where the third one is to design a prototype for a line following mobile robot with function of measuring temperature and humidity using DHT11 and display using OLED.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahmi. I will explain project goal. The first one is the first priority and the main objective of this robot is to automatically move following a lines. The second objective and priorities are to detect humidity and temperature of the robot surrounding. The next is circuit design. This is a circuit design to our project that is consist of first is Arduino Uno, motor driver, motor, two IR sensor, humidity sensor and OLED. The next is the circuit include Arduino Uno RT. The microcontroller used for various applications. The next is L293D motor driver interface between Arduino and DC motor. Next is DC motor controlled by the motor driver. Next is IR obstacle sensor detect obstacle in the robot parts. Next is OLED display. Utilize OLED technology to visually display information. Next is DHT 11 humidity sensor used to measure and humidity with data visualization on the OLED screen. Arduino Uno R3 control the circuit. The motor driver handle motor driver. Two RF sensor guide the robot along a black line, and RF sensor detect obstacle. The DHT11 humidity sensor measure climate data, and the OLED display visually present relevant information. Thank you.
Um, my name is Muhammad IQHRAM, this reminder. Today I will explain list of components. Here we can see is Arduino Uno, which is the brain of the robot car. The second picture is OLED display, which is to display the temperature and humidity of our surrounding. In here, we can see L293D motor driver, which function for the motor to move. And here are the motor to make the wheel move. IR sensor function is to sense the black line, so the robot can move forward in straight line or following the line. For DHT level humidity sensor is to detect the temperature and humidity. The car chassis are for the body of the robot, the body of the project I mean, and the breadboard are used to connect the circuit. Ya, panjang tu. Assalamualaikum, and my name is Muhammad Ikram, and for today's presentation, I will explain about our programming flowchart. First, we input the library, which will then the robot will configure the OLED. After that, the robot will also declare the Citron MD motor for the first motor and then the second motor. From here, the robot will start to activate, which if the pin equal to 0, it will start activated print hello we are group 5, and then it will also print I'm a robot. Uh, from then on, it will also start working on thread 1 and thread 2. For thread 1, the robot will usually focus on their objective, which is following a straight line or black line through using the sensor. Here we can see uh, if the IR sensor left are low and both are low, it will go forward, which means if the robot detects a straight line or a black line, it will go forward. But if the IR sensor left is low, it will automatically go to left. While if the IR sensor for the right one are low, it will uh, go straight to right, move to right. If the both sensor are high, the robot will stop. And lastly, for thread 2, this is for the DHT, which is for detecting humidity and temperature surrounding the robot. Firstly, it will initiate the DHT, which is read 11, DHT temperature, DHT and DHT humidity, which will clear the OLED. The OLED will also print on the display, which is temperature, Celsius, and humidity. Uh, if the sensor detecting which is high, OLED will display temperature, Celsius, and humidity depending on its surrounding. Uh, I think that's all for the flowchart. Thank you.
Assalamualaikum. Now I'm going to present about coding that we use for this line following robot. So we are using Arduino IDE. First step, we will include all the library, which is GBOS for real-time operating system, then Citron motor driver, then SSD1306, which is for OLED, and the HT library. Then we're going to declare the pin for motor driver for motor 1 and motor 2. Then for thread 1 is for line following robot. we will declare the pin for IR sensor for button. So when button is low, button is high. When IR sensor and IR sensor for both left and right is high, robot will move forward. If IR sensor left is low and IR sensor right is high, it will turn right. If if IR sensor left is high and IR sensor right is low, it will turn left. And if both of the sensor is low, robot will stop. Now, for track 2 is to read and display temperature and humidity using the HT sensor. We will print the temperature, the Celsius and humidity, and also will make a delay for 1 second. After that, we will print uh, our group number at the LCD at the outlet, and then we can control the motor speed for boost the speed for robot to go forward, reverse, left, and right. So that's all for coding. Thank you.
So for the RMS, pragmatic scheduling. So at the left is list of related duration. Thread 1 startup duration is 4 microsecond, and thread 1 duration is 8 microsecond, and thread 2 startup duration 357,813 microsecond, and the last thread 2 loop duration 694,782 microsecond. And at the right is a priority assignment table. So for the priority is 1, 2, and track 1, 2, and for the period and deadline is the same number, 2525 and 730 and 730. So for the CPU time, because you can use the thread loop duration. So for the thread 1 loop duration is 8, and thread 2 loop duration is 694,782. So this is for the calculation RMS is pragmatic scheduling. So for the track one is schedulable, and track two, when we do the calculation, is also schedulable. So that's all from us from group 5, and thank you.